Hello everyone, just going to introduce ourselves quickly. I'm Matt Starling and obviously Mac Daring. We are wireless project engineers who work for Natilic.
And you can also probably know us as the WiFi Ninjas.
It's a podcast and blog that we started at the beginning of this year. So today we're going to be talking to you about what we think is the most exciting thing about Wi-Fi, which is
the real-time location services, RTLS.
Yeah. These are a few of the vendors and the technologies that we're going to be covering, and you'll see in a second, this is a visual representation of how excited me and Matt get when we start talking about RTLS. So if at any point today we start jumping up and down, you know why. So yeah, you can work out which one of us is each dog.
Matt is the paddle.
They're going to take you through a little bit of theory on what the different kind of like functionalities of RTLS and the wording, and then we've got some demos where we're going to show you it working and actually working with some of the Natilic customers and some testing that we've done. So yeah, just touching on what is RTLS, like what different technologies are there, what different tracking methods are there, and then what do you need to do to design for an RTLS RF deployment. And like I said, we'll show you guys some real live examples and some demos.
And also we will talk about why would we like to use the RTLS. So RTLS can be used for tracking indoor. So whether indoor wayfinding. So you can find your house, you can find your meeting room, you can find your toilet, if that's your thing. You can use it for marketing purposes, to engage with your clients, to push notifications, to trigger some actions if they are running applications on the mobile devices, and for network-wide presence and analytics stats.
Okay, so you might be thinking, oh, who wants to use that sort of technology? Who wants to use it? So retailers would probably want to use this in technology, hotels, airports, hospitals, education, enterprise offices, public spaces, potentially in your home, but probably not in the UK because it's probably too small. So,
and this is what we are going to test today. So we'll focus on the Wi-Fi trilateration, on Wi-Fi angle of arrival hyperlocation with Cisco, with Mist vBLE directional arrays, and also we will touch upon API and mobile SDK.
So really there's two popular methods of location tracking, and the first one being Wi-Fi. The Wi-Fi is the most popular one at the moment, we think, because it also provides access to the network, which can also give people like presence and analytic stats, like network-wide stats. You get different levels of accuracy with Wi-Fi, which we'll cover in a few slides' time. And client applications for Wi-Fi tracking, they're optional, but they can be quite challenging because there's no way of the application of knowing the Wi-Fi MAC address of the device that it's on. And the APs, they track the signals from the devices and then they feed that back to a server or cloud to compute the station location.
And there is a BLE, so that's probably the second that is becoming the first most popular technology that we use for indoor location tracking. And vBLE versus BLE. So we can think about what's the difference between the BLE and vBLE. So normally a BLE, Bluetooth Low Energy, it was based on like a beacons around the room, battery operated, where you have to recharge the batteries like every year, change the batteries. And now vBLE, it moves this functionality to the access points, where you could put virtual places in your map using access points in the room to trigger different actions in different places of the room, which is quite good. And now BLE, does it transmit or receive data? And the answer is it does both. So for the most accurate location tracking, you would receive data from the beacons, and then you would probably send it over to the server, to the cloud, and that makes it accurate because the cloud calculates the location of your client, sends the location back to the client. So it's a completely different, opposite way to how Wi-Fi is doing things. And for that, we need to have an application, and Wi-Fi doesn't. And that's BLE.
Okay. So now we're going to move on to the different methods of RTLS tracking. And just like Mac, we're going to start with the most simple technology that there is, which is cell of origin. So when you first enter a room and it's the first AP you connect to, that's kind of cell of origin tracking method. It's very simple. It can be used for some zone-based analytics, but it comes with like very careful planning and RF design. But you're not going to get super high level accuracy from this kind of information. More kind of just around like presence analytics stats.
Yeah, and now there is like a more complicated method, which is similar to MAT actually. You do not need to have one AP, you now need to have at least 3, and you'll be triangulating, well, it's trilaterating data, it's location based, using the RSSI to calculate XY coordinates of a client.
And then the next method of tracking is angle of arrival. So if you think now, like, if we're talking like Cisco terms, like the Cisco Hyperlocation access points or the Hyperlocation modules, they've got the built-in multiple element antenna array. In the 4800, it has a 16 element multi-antenna array, and then on the previous generation models like the 37 or the 3600, you have to buy an external module which would come with a 32 element antenna array. And then you really need to have at least 2, but preferably 3 of these sensors to track the location of the client. There's the marketed accuracy of trilateration is around 7 to 10 meters, or potentially 5 to 7 in some cases. But in angle of arrival, they say the marketed accuracy is like 1 to 3 meters. So XY coordinates are calculated here.
Okay, and now Mist vBLE. So the design for the vBLE implementation is very similar to what you would have done for angle of arrival hyperlocation. And the accuracy is very similar. It's 1 to 3 meters as well. And I've already discussed how is it working, so it's different to Wi-Fi. And what happens if you, what I didn't discuss yet, what happens when you don't have the application using vBLE is then your device can still be tracked, but it's being tracked as an asset. So it won't be calculated as frequently, but it will still work.
Okay. So now moving on to the functionality of RTLS, the first one being the presence and analytics. This is like your network-wide stats, like your dwell times, how many visitors are visiting my buildings, are they repeat visitors, like if they sign in with some sort of like social media platform, you can find out a little bit more information about them, potentially how they use the building, that kind of level of analytics, and this usually relies on the Wi-Fi.
And then you have a location, that is a location-aware services, so a blue dot experience, and the zone paths analytics, where you want to understand where people move throughout your premise. And we can, of course, use different technologies for that.
And then the third one being the engagement and action. So it uses the presence and analytics with the location to kind of like build a more personalized experience for a user. So say you are visiting your favorite shopping center, and when the last time you were there, you ended up buying a pizza from your favorite pizza place. If this is tied in with the back-end CRM system with the retailers, the next time you attend that retailers, it could send you a push notification like, hey, welcome back to the Wi-Fi Ninjas shopping center, go get a pizza at 50% off at your favorite pizza place, because it knows all that sort of information. Okay, so the RTLS design, very quickly. A few tips. Tip number 1, so APs, normally they are located around the outside perimeter of the coverage area to create a convex hull. Yep. And then the clients, really, they need to be inside of this convex hull with a very solid RSSI, at least minimum of -65, and heard by 3 access points.
And ideally, we should use RTLS dedicated radio for RTLS location services, because if we don't have this radio, then we'll be using the client serving radio, which will make it not as efficient, as we'll have to go off channel.
Okay. And then ensure line of sight is maintained between access points and clients. I know everyone in here is a fantastic wireless professional. No one installs APs above ceiling tiles or anything like that, right? If you're doing an RTLS design, well, they're probably not going to have the best RTLS if they do that, because you really need to maintain line of sight between your access points and your clients. So do not mount APs behind ceiling tiles.
And also, when you're mounting access points, they should not be mounted too high, as you have the donut shape, like around 30 degrees down and around the access point. So if it's too high, it will not work too accurately. Mm-hmm.
And then validate secondary and tertiary signal strength in your favorite survey tool. We only have one, of course, Ekahau. We use Ekahau. If anyone doesn't know how you can do that, when you're looking at a floor plan and the coverage, if you go to the options button and then just show all channels of the tertiary signal, you'll be able to view what the signal looks like from the third access point perspective.
And a design example. So this is our office, where this design is focused on just data. And this is enough to provide enough capacity for the amount of users that we have in the back office and in the meeting rooms. And here we have just 6 access points.
And now if we compare that to the RTLS design that we've done in the Natilik office, you can see the number of access points has actually tripled. That's because we're creating that convex hole around the perimeter of the building. We're putting the APs in the middle to create that trilateration. It may look a little bit heavy around the boardroom, but the walls are really thick brick walls, so they attenuate the Wi-Fi very well, just like what Mac does.
And actually we've done it at Peter's class, right? When we were trying to force roaming inside one room, and I was just standing in front of both access points, like in between them, and the roaming was triggered.
Okay, so we're going to move on to our actual demos and our testing and some of our actual real deployments we've done at some customers.
Okay, so this is our test environment. That's at my place. So we have like an open space of 7 by 10, 7 by 9 meters, and we have 3 tripods in a very strategic locations, ensuring that they are mounted perfectly. So we've used the laser, so they are leveled. The azimuth is all, properly done. They're all facing north, and we have a very, very proper looking model walking around. So you can see Matt holding his phone.
Yeah. You'll notice in this one as well that there's actually furniture at Mac's house. The first kind of one test we'll do, and you've seen a few video and slides time, there was no furniture, like no heating, they just moved in, and we was like, this is the perfect test environment for some RTLS, so let's just get in there and chuck
Probably better for Wi-Fi than it was for Matt, because he was freezing to death.
Yeah, no heads up, like, oh yeah, bring a jumper, like might put some heating on, but apparently not. Okay. So the trilateration testing that we did first, we was using Cisco with CMX. So to just quickly look at the components that we use to do this. We use the Cisco access points with the this one here, we just use Cisco access points with the Cisco wireless LAN controller. We use Prime for that function actually, and then with CMX. Potentially one day in the future, you could go straight into DNA spaces.
Yeah, but we still couldn't do it because we are using 9800 Cisco controllers, and the publicly available code was the one version behind the minimum version of code that would allow us to connect directly to DNA spaces. And also we could theoretically use DNA Center instead of Prime now, as it does support Maps services.
Yeah. And then we did some trilateration stuff with Meraki access points, the Meraki dashboard, and then integration with Purple. And then just to give you a bit of a flavour for what it looks like inside of the Cisco DNA spaces and Meraki with Purple, you can see where the APs are, you can see probing clients, you can see non-associated clients. If a client's connected and they've signed in with a social media platform, we've actually blurred out the picture, but it's a woman, and then like all of her, where she lives, also likes her interests. So for a retailer, that might be quite interesting to know, like the trends of how a certain demographic uses the building, so then they can put targeted marketing in different areas or move potentially different stores in different places.
Mm-hmm. And this is our test for the trilateration. So you can see that we have here 3 test locations. Test number 1 is inside the convex hole of the access points of the coverage. Then test number 2, the red one, is on the edge. Test number 3 is slightly outside. And what we have seen in this really perfect lab environment is that inside the convex hole, we had a distance, we had an accuracy of around 2.7 meters with 90% of certainty, which is quite mind-blowing for just a simple trilateration. If you move slightly outside onto the edge, to the convex hole, then it goes down to 3.4 meters. So in the lab, we had really 3 to 4 meters of accuracy, which is very good. Marketed accuracy is 5 to 7 meters, but we've done several implementations of Wi-Fi trilateration using Cisco and Meraki, and it was around 7 to 10 meters in a really, really good environment.
Okay, so now we're going to move on to our hyperlocation testing. Very quick review of what we used here is the hyperlocation access points, the Cisco wireless LAN controller, Cisco Prime, Cisco CMX, and then optionally you can use DNA spaces. And then the screenshot here is of the CMX server that we've got running at the Natilik office. And what you can see here now is the defined zones that we've created. The zone in particular I want to highlight is the showcase. The showcase is if you are interested in buying a new technology at Natilik, you can come to Natilik, have that technology demonstrated to you at the showcase. Why is that interesting for now, and why am I pointing it out? Because on CMX, you can have a look at the paths that people have taken. So what path do clients take before they come into the showcase, whether they go after, that kind of information. You may be thinking, why is that important for an office? But if you go back to the retail example, the fact that you can get an understanding how people are flowing through your building, how is it optimized, how is it used, who is using it, what way are they using it, you can then really start to analyze and understand your building a lot better just from your Wi-Fi deployment.
Mm-hmm. And now, how accurate is the hyperlocation, especially against like a different RTLS method? So we can see here that the circles, well, ellipses around the test spots, they are much smaller. And in the test number 1, inside the convex hull, we had a accuracy of 73 centimeters, which is absolutely mind-bending. But when you move outside of the convex hull, it goes down to around 2 meters with 90% of in 90% of cases. So in a lab, we had around 1 to 3 meters accuracy. Well, when you start moving around, as you will see in a sec, the accuracy will go down slightly. So in the lab, 1 to 3 meters versus marketed 1 to 3 meters. And in the real life, it depends. If you start moving, it will not be as accurate, but it should still be within this 3 meters marketed accuracy.
Yep. So now we have actually a little video for you guys. We'll just talk you through the video. On the left-hand side is my iPhone, where I've downloaded the CMX app and I've connected to the server. And the middle screen is of the actual CMX server, just purely tracking the MAC address of my iPhone as I walk around. And then on the right-hand side is me walking around Mac's front room. And for what we can see here is purely, we've not drawn any paths, any rails, it's just purely the access points feeding back the signal to the CMX server, which is crunching the numbers of where I am as I move around, which we can see here. It's actually really good. Like it's not appearing more accurate because it's snapping us to the path. It jumps around a couple times, but that's kind of expected because the refresh rate is around 2.5 seconds here. So it's really good accuracy, and it actually worked very, very well. We was pretty happy with it, weren't we?
Yeah, it's absolutely amazing.
So yeah, we can just see as everything here is within the marketed accuracy for our testing, which was really good.
Yeah, and of course we would be able to draw some rails to make it appear more accurate than it really is. So the rails, it means like, you know, let's say here you would draw rails around this room and throughout the middle, because you will never go through the chairs, right? So even if the system calculates your location that you are inside, like, you know, the area with the chairs, it will snap you to the closest path. So your location on the screen of your phone will appear much better than it really is in the real life.
So now we're going to take you through our demonstration and our testing we did with Mist and the vBLE. Just looking at the components that we use for the Mist was the Mist access points connecting straight back to the Mist dashboard. And we can now show you just a couple of screenshots of how the location analytics look on the Mist dashboard. So you can see the floor plan, you can see on the right-hand side, you can see the dwell time, how many visitors, what devices, and the different trends. And then now we're going to do the same video and testing.
Yeah. Okay, so this is our testing of Mist. We have our favorite model on the left-hand side. On the right-hand side is the application from his phone. And towards the left, you can see the blue line, which is the wayfinding path, the rails in the Cisco world, that Matt will be snapped into. And the big dots, like an orange one that Matt is about to hit now, they will trigger some actions, and in this case it's the browser alert. So he's next to the kitchen, he's in the kitchen zone, so we opened like a, you know, how to brew a coffee thing, and now he moves around and notice that the mobile sensors they are being used, and the refresh rate is a little bit faster than with hyperlocation, so it refreshes about every second, and that's true for both the mobile SDK and for the dashboard. And now he has hit another vBLE browser alert, so that's the nicest podcast for Wi-Fi you can find there. And he continues walking towards the last access point. So this feels like Google Maps inside, and yeah, it's absolutely amazing.
How does the distance from the AP affect the accuracy location?
Well, it does, but
we turned the power down for this.
Yeah, we had to turn it down quite a lot.
Yeah.
So if you're like in a shopping mall, as you said, and if your APs are all the way up there.
It's configurable. You can configure like the power levels for the BLE the same as you configure the power level. Not the exact same, but same principle that you can configure the TX power of the access points for Wi-Fi clients.
And you have to calibrate it.
Yeah, the interesting thing about Mist is that it actually starts to learn about the devices as you move around and the calibration. So as you start to move around, it starts to build a profile on each device, and then for each client side, it gets self-learn. Yeah.
We don't want to go too deeply because we don't have time, but
let's catch up after because we've got a couple more stuff. So now we're going to talk about the location API that we've done at Liberty London. Has anyone here not heard of Liberty London? Some people may not. Okay, it's Liberty London. They are a luxury goods like retailer in London. So there's a very old Tudor building, lots of thick brick walls. They've got 3 main sections, which has got about 5 or 6 floors, and then they've got atriums that run from the top to the bottom throughout the atrium, throughout the floors in each section. And then they come to Natilik because they needed a wireless network to match up to the prestigiousness of the store.
Okay, so very quickly, this is what we have at Liberty. This is obviously data design. So this is not designed for RTLS. The idea behind it was to have a presence in analytics, network-wide stats. So this is Meraki with purple on top of it, and in purple we could use this, we could view these stats very, very nicely. We have a graphs like, visitors, new versus old, repeated visits, and like a profiles of people if they used how do you call it, social media to enroll to the Wi-Fi customers network. So presence analytics, it works great, but during the test phase, the business they've located like a nice location tab, and they started asking, oh, what can we do with this location tab? And I said, oh, don't go there, but they did go there anyway. And in the location tab, you can do something like zone paths analytics that Matt has shown based on the CMX. So you can do the same in purple. You can understand the flow of your users. Which zone do they come from? Which zone do they go to? If you put a promotion in, or if you do some changes in the area, how does it affect the flow of the users? Do they come back? Do they spend more time in this zone? So I can understand that the business really wanted to have it. But with this design, how would it work? We have Meraki Wi-Fi that uses trilateration. So that's what Meraki does. Meraki doesn't do hyperlocation. Meraki doesn't have directional antennas, so it does use trilateration. And for trilateration, we need to have 3 access points. And what happens when you don't have these 3 access points in a zone? Yeah, then you turn into Superman. So you develop superpowers, and when you take a look at the paths inside the purple, then you start on the ground floor. 5 seconds later, the user goes to the 5th floor, then back to the ground, and they jump like crazy, like there is no tomorrow.
So people that shop at Liberty are basically superheroes, is what we were seeing.
Yeah. So from our infrastructure perspective, what has happened is Meraki has used like 2 access points to calculate the location from the zone that the client was in, and then it has taken like another access point from a different zone and from a different floor through the atrium, and it used those 3 access points, not all in the same zone, to calculate the location. That's why the users were flying. So we took a step back and thought, what can we do to give the business the cell of origin accuracy for the zone paths analytics with the system that we've already had. Based on our very detailed survey that we've done together with Matt, we put like several access points on a stick to understand how many more access points we would need to have a proper trilateration functionality, and we would have to triple the amount of access points, so it was deemed unpractical, unfortunately. So we had to work with what we had. And then based on our survey, with 90% of cases, our clients were associating to the access point, best access points in the zone that they were really in. So that's what we used. We used the MAC address of the access point, that we know exactly in which zone this access point is located, what time it has seen the client with a certain MAC address, RSSI, so we filtered it to only give us the highest RSSI values seen using Meraki Location API, to return venue, and venue is a zone. Then this raw Meraki Location API data has been given, they subscribed, the developers team at Liberty, they subscribed to this data, and then they used it to visualize it nicely to give business the access to the zone accuracy location analytics. And that's just the tip of the iceberg, how you can use the APIs to give it what you really want.
Okay. So now we're going to show you what we've done at Natilik offices with Location API from our Cisco deployment with Cisco CMX. We're very lucky at Natilik to have some very good developers as well. And a guy there called Darren, he created a chatbot on WebEx Teams and called it NatBot. Chatbot, Natilik, NatBot. That's how we got there.
Really?
So what you can do with NatBot is you can go onto it and say how much holiday do I have left, what's the trains like from the offices today, how many meetings have I got today, that kind of information. So we looked at that it tied in with the CMX APIs, what we could leverage here to try and make this a bit more interesting for people whilst they're in the office. So now you can go into the chatbot when it's now integrated with our Cisco CMX location deployment, and you can go in there and say who is Matt, and at the very early stages we were playing around with it, just returning the information about who I am, but it'd also say if you're in the London office, why don't you go and say hi, he's on the 3rd floor. but we haven't got a full hyperlocation deployment at the moment. We're basically using Cell of Origin, is being upgraded at the start of next year, and it'll get a lot more accurate. But then this was the early stages of deployment and playing around that we started doing with Darren. So we looked at next, like what else could we do, and what other platforms or services that we can use. So I'm going to play you a little video now of us talking to the chatbot. They're still in the development, but what it basically does, when it goes on to now, it's not coming out very well. It's basically saying who is James Hinton. It's going to return a floor plan based on where he is and tied to that zone. And then there's 3 icons there. The third icon that it is clicking on now is taking you off to MapWise, which is like an indoor wayfinding location services. So it'll draw a path from where your current position is to where James is. And it tells you how long it's going to take, how far it is, which we think is really, really cool. And it's actually being used in the office all the time by non-techie people. As soon as they found out you can do this, and we use it all the time when we're in there.
We didn't see that coming. So last month we were talking about it in Prague. It was like a first release of this functionality, and now pretty much entire office is using it on a day-to-day basis.
Because you want to try and find someone. It's only 2 floors in the Tillich, but there's a 2-floor gap. So that if someone's not on that floor that you're on, are they upstairs really, or are they not in the office? So you can just go on there and say, oh, where is Mac? At home skiving is usually what it comes back and says, but you get a point. But if you've got this deployed in a huge office with loads of floors, it could be really helpful. And especially like if you don't know who everyone is, like Natilik have hired a load more people since I've started. I can't remember who everyone is. If you could go in there and say, oh, who is this person? Like, where are they? Or like, where is my meeting room? And return this information. I find that a lot better than having to bug someone and be like, oh, do you know who this person is?
Because you're antisocial.
But that's really like the sky is the limit here. Like we were just at the very early stages, and it's going to get better. But just showing you guys what you can do. We've showed you how to do the theory, and then how you do the deployment. But then what are the actual cool things you can do as well. So
and very quickly, our new plans we want to take it one step further. So we are already talking with the proper mobile SDK integrator, a nice company. And then we will have a Bluetooth experience that will be offloading, like a Google Maps from outdoor to indoor, and we'll integrate it with calendar. So when you look for the meeting room, it will give you an information about who booked this meeting room. You can book it from the chatbot directly, and also we are looking at integrating it with voice assistants. So I can ask my Google Assistant on my phone, like, where is Matt Starling, and it will always tell me that he's in the toilet.
So the sky's the limit really. If anything you think of, you could probably integrate it with APIs and stuff now. But yeah, we'll hopefully next year, once we've got it all fully deployed, we might come back and show you what it's actually looking like with some other cool stuff we've done. But we're just going to summarise now between between RTLS, the Wi-Fi triangulation, and the hyperlocation. You can see the solid lines are the trilateration testing that we've done, and then the hyperlocation is the dotted line. So the accuracy obviously is a lot higher with hyperlocation from our testing. I don't know where that slide's gone.
Okay. And there was one slide missing. Don't worry about it.
Oh, there we go. I found it. He asked me to change it this morning. Literally this morning, he sent it to me whilst on the train up here. I'm
sorry, but it's quite important from our perspective, because when you put these 3 different guys together and you want to think about how can you leverage this RTLS functionality to give benefit to your business, you really want to understand not only the accuracy in the real world and in a lab versus marketed, is it really better than they say or is it worse than they say, but you also want to understand what is the location computation frequency of the location of your client. So with trilateration, it doesn't matter if it's Cisco or anyone else, but trilateration is between 10 to 15 seconds normally, and also since they assume that it's about 5 to 7 meters accuracy, when you move 5, oh, he's attacking me now.
Trying to hurry up.
5 meters away, it won't even update your location. With Cisco Hyperlocation, your location is updated every 2.5 seconds, pretty much, which is still very good. So you can simulate fluent movement of your blue dot on the map using the mobile SDK and stuff. So you can do magic stuff with it. But with Mist, it's happening every second. And I put some little stars there. So star number 1 for Cisco, Wi-Fi is on, client is active, screen is on, and no application is installed. That's a normal use case for Wi-Fi-based location services. So you don't require an app. With, however, BLE, you always need an app to have a high accuracy location analytics. So we treat it as a standard thing. So you would have an app with, let's say, a Mist. And that's how they fare when put against each other.
All right, that's it. We took a bit longer, sorry guys, but thank you very much.